Good day, everyone. So, we're here now at our Physics 121 class. So, I'm Neri Cloyd, and we're here today to have our experiment number 4. And we're tasked to simulate, using an app, the problem number 2 in our finals. And also discuss the Kirchhoff law and a little bit about ground. Now, let's start. So for the first is junction rule. This is also called as the Kirchhoff current law. So this states that the sum of the magnitudes of the currents directed into a junction equals to the sum of magnitudes of the currents directed out of the junction. Now this makes sense since um, the what it states is that the current that ingoing is equal to the current that is outgoing. So let's have an illustration. So there is junction here. Then the sum of the current going in, which is this, is equals to the sum of the current going out. So let's have this illustration. Now we can see. So if we have these two values for these currents, so the sum of these currents, which is incoming for this junction, is equals to the sum of the currents outgoing in this junction. So the first Kirchhoff law also states that the sum of all currents living in a node in any electrical network is always equal to zero. So it is equal to zero since what comes in into the node also comes out. So we can see here that the summation here we have here is equals to zero. So now we have the Kirchhoff's voltage law or the loop rule. So it states that the sum of the voltages around the circuit loop is zero. This means that the voltage drop that we will have and the source, we will be equating it with zero or equals to zero. And also in any closed loop network, the total voltage around the loop is equal to the sum of the voltage drops within the same loop, which is equal to zero. So we can see here that the collective voltage drop is equals to the total voltage of a loop. So let's discuss about ground. So ground is the reference point in an electrical circuit from which voltages are measured. A common return path for electric current or a direct physical connection to the earth. So ground is a safety measure and act as a huge reservoir for excess charges to pass through. In simple terms, the ground serve or caters excess charges so they can have a safe place to go. Now let's start with our simulation. Now let's rotate this, then add the source. You'll have two sources, then three resistors. You place it. Resistor 1, 2, and 3. So we're gonna connect it. Then here. Now it's all connected. Now let's correct the source since what we have in the given is the positive, the negative. Now let's edit the value. 500 ohms for the resistor 1 and 1 kilo ohm for the resistor 2 and 2 kilo ohm for the resistor 3. We also have the 2 volts for the second or V2 of ours. And let's add a ground to it. Now let's see. Now we can see here. the flow of the currents. Now, you can see here that the resistor 2 have 2.57 milliampere in its current value and 2.57 for its voltage drop. So we already discussed the Kirchhoff law and also the ground and simulated the assigned problem. So that would be all for today. See you and have a good day. See you at our next video. Goodbye.